So we are going to be adding and subtracting polynomial expressions. So let's break that down. We know how to add and subtract, right? Okay. What is a polynomial? Okay, I'll ask you an easier question. What's an expression? How do we know what an expression is? It doesn't have an equal sign. Okay, polynomial means there are multiple terms. So for instance, so let me just add this. Polynomial could be something like 3x to the third minus 2x squared plus 5x minus 7. Okay, so this is a polynomial. It has multiple terms. Everything that is separated by your positives and negatives is considered a term. So how many terms are in this polynomial? 4. Okay, there are 4 terms. Now, if there's only 2 terms, it's known as a binomial. 1 term is known as a monomial. 3 terms is a trinomial. And typically after 3, we just call it a polynomial. But the general classification for anything that looks like this is going to be a polynomial. Okay? When we were doing exponents, we were combining like terms. Remember when we did that, they had to have a couple things in common. What makes something like terms? What do they have to have? Who remembers from last week? What are the 2 things you have to be considered like terms? Same base. Okay, I'm going to call it the same variable. So same variable, same exponent. So in order for something to be a like term, it has to have the same variable and the same exponent. If it doesn't, we cannot combine them together. So like we're going to add all the apples together and we're going to add all the oranges together, but we're not making a fruit salad. Okay, you can't combine it all. Okay, well, just kidding. You have to combine things separately. You can only combine the apples, you can only combine the oranges. We're not putting it all together. Okay? Now, we're going to talk about something called standard form, and you probably talked about it last year in IM1. For us, standard form means we're writing it from the highest exponent to the constant. So highest exponent to the constant. So you'll notice in my polynomial, I start at x to the third, and then it goes x squared and x, and my constant, the one without a variable, is at the end, which is the -7. Okay, so highest exponent to constant is standard form. So all of your expressions should be written in standard form. We okay with that? Questions on what like terms are and how we're going to write them? Okay, so let's look at a problem. This is where our colors come in. Now, some of you aren't going to want to use colors. Some of you might want to cross things out. I think colors are helpful. You'll see what I'm going to do as I go through it. Okay, so we have 5x squared plus 2x minus 1 plus 4x squared minus x plus 2. So if I look at this expression, what is my highest exponent? 2. So I have a 5x squared, and this is where the colors come in, so I'm going to underline 5x squared. What can I combine that with? What else has an x squared? 4x squared. When you're combining like terms, you are just adding or subtracting coefficients. So 5 plus 4, 9. 9x squared. Do not change your exponent or variable. You are just adding and subtracting coefficients. What's my next highest exponent? 1. So I have a 2x and I have a -1x. So 2 minus 1 is 1, and it's a 1x. If you just want to write x, that's fine. You can put the 1 in front if you want. The nice thing about about identifying things too as you go is you figure out what's left. Again, some people like to cross it out because you don't want to reuse something. What's left? My constants, so -1 plus 2. What's -1 plus 2? 1. So my new expression is 9x squared plus x plus 1. It's going to be the prettiest page of notes you've ever taken. Are we okay with that? Okay. Let's try another one together, and then I'll give you a couple to try. Okay, highest exponent, 3. I see a 3y to the third. Do you see anything else? Nope. So we're just going to write 3y to the third. Okay, what's my next highest?
Y squared.
The y squared. Is there anything else I can add with that? Nope. So we're just going to rewrite it. What's after that? The 2y. Is there anything I can add with that? Nope. And last, my constants. 1 minus 1, 0, so I don't need it. Okay, so highest exponent to constant. Can I give you 2 to try?
Sure.
Okay. All right, take a second and try both of these. Highest exponent, 3, so negative x to the third and a 2x to the third, giving me a 1x to the third, right? Because -1 plus 2 is positive 1. My next highest is negative x squared, and there's nothing to combine that with. Then I have a negative 2x and a positive 2x, which cancel. You do not need to write 0x, because what's 0 times x? 0, so it goes away. And the last thing I have is this negative 1. So your answer should be x to the third minus x squared minus 1. Okay. Number 4. My highest exponent is 1. 1x plus 4x gives me 5x. And negative 1 minus 6 is negative 7. How do we do?
Pretty good.
Pretty good. Okay, so let's add a layer. Okay, Okay, so here's a new one. Everyone's writing down this new one. What's the difference between this problem and the last four? It's subtraction in the middle, right? Okay, this is where people mess up on these. In order to get rid of that negative or that subtraction sign, we have to distribute the negative to everything behind it. Okay, so we're changing the sign to everything behind it. Because what number is really attached to that negative? A 1. So we're distributing a -1 to all the terms behind it before we can add or subtract. Okay, so I'm going to just rewrite y squared plus y minus 1. And then I'm going to distribute. It really is just changing the signs. So it's going to give me a positive 2y squared, a negative y, and a -1. Now I don't have to really worry about, I don't have to put parentheses back in, and I'm just going to combine like terms. What is my highest exponent? Y squared. So I have a y squared plus 2y squared for a total of 3y squared. Next is y. I have y minus y, which is 0, right? 1y minus y is 0. And then -1 minus 1, -2. Okay, so you're distributing through that negative. Then you can combine like terms. That is the one thing students mess up the most often. Are we okay with that?
Yeah.
Okay, let's try one more together, and then I'll give you 2 to do on your own. Oh, okay. Do you need? Do we have it? Okay. Number 6. Let's see. Okay, so first step is to distribute through that negative. So I'm going to distribute that negative. Some of you will find tricks around having to write an extra step, and that's fine if you just change the signs in order to not mess up. I like to rewrite it. So I have 8y minus 7, and if I distribute a negative, I get -1 plus 3y. My like terms are 8y and 3y. 8 plus 3, 11, so 11y. -7 minus 1, -8. We okay with that? Okay. I'm going to give you 2 to do, and then we are done for today. This isn't too bad? Good. Okay, take a few minutes and do number 7 and 8, and then I will have homework for you. All right, number 7. So I have a -x to the third minus 2x minus 1. If I distribute that negative, I now have a positive x to the third, a minus 2x, and a minus 1. Highest exponent. Negative x to the third and positive x to the third gives me? What? 0. Negative 1 plus 1 is 0. Okay? Next, I have a negative 2x and a negative 2x. So negative 2 minus 2, negative 4x. And then I have a negative 1 and a minus 1. So negative 1 minus 1 is negative 2. How do we do on that one?
Pretty good.
Pretty good? All right, last one. 2q squared minus q minus 8. And when I distribute, I get a positive 2q squared, a negative q, and a positive 4. Highest exponent squared. So 2q squared plus 2q squared is 4q squared. Then I have a negative q minus q. So negative 1 minus 1 is negative 2q. And lastly, I have a negative 8 and a positive 4. So negative 8 plus 4, negative 4. So really, the hardest thing in this lesson is making sure you can add and subtract positive and negative numbers. Right? Everyone okay with this?
Yeah.
Awesome.